the next question we need to sort of ask ourselves, once we've figured out sort of in each quadrant, is each trig function sort of positive or negative? Once we've done that, we need to sort of see if we can use that information to sort of help ourselves out. So one of the things that we'll sort of do first is, so given the sign, positive or negative sign, of trig functions, let's figure out which quadrant we're in. And I'm just going to underline this whole thing for no real reason. I'm going to box the title. We're just going wild with various ways of highlighting our information here. So let me sort of give you an example, right? So let's say that I know, so if the sine of theta is positive and the tangent of theta is negative, which quadrant are we in? Right? So one of the things, we didn't necessarily sort of lay this out explicitly, but once in the last video where we went through all the different quadrants and whether or not the different trig functions are positive or negative, one of the things that happens is, so all of the trig functions are positive in quadrant 1, and then as you move through the rest of them, right, they sort of go back and forth. But in the end, each trig function is positive in 2 quadrants and is negative in 2 quadrants. And they sort of go back and forth between them. Only the reciprocal functions are sort of synced up, right? So it's not like sine and tangent are always in sync. They all sort of go out of sync. So if you give me positive or negative information about any 2 trig functions that aren't necessarily just reciprocal functions, I can sort of tell you which quadrant you're in. It's almost like a little logic puzzle. So let me show you how it goes, right? So if the sine is positive, that's going to happen either in quadrant 1 or quadrant 2, right? Because sine is associated with the y-coordinate and the radius. The radius is always positive, so it really is just based on the y values. So positive y values in quadrant 1 and quadrant 2. Tangent is negative. Tangent is a mixture, right, of the x value and the y value, so you need them to be out of sync. So tangent will be negative in quadrant 2 or quadrant 4. So what's the only place where both of these things happen, right? We're making almost like a little sort of Venn diagram, this little logic puzzle. So I must be in quadrant 2, because the only place where sine will be positive and tangent will be negative, where both of those things are happening, is that second quadrant. Let me give you another one. So if cosecant of theta is negative and cosine of theta is also negative, which quadrant? So first and foremost, let's just figure out what's going on for each of these. Cosecant, right, this is going to sync up with our sine function, right? So this means the sine function is also negative because cosecant and sine are just reciprocals of each other, so when one is positive, the other one will be positive, and same thing when they're negative. So where is the sine function negative? That's going to happen where the y value is negative, which is quadrant 3 or quadrant 4. Cosine, one of our big 3, right, also negative. That syncs up with our x values, so the x values will be negative quadrant 2 or quadrant 3. So, ladies and gentlemen, which quadrant fits both of these categories? It's got to be quadrant 3, right? So the only place where both of these things are happening is going to be quadrant 3. So you might say, Professor Johansson, that's good, I guess. Like, why do I care about this? How is this useful? And what I would say is, let me take you on a journey of knowledge. Let's kind of like use this and leverage it. We'll kind of do something similar to what we did in 5.2. So let's say, so given a trig value, so for example, let's say we know the sine of theta is like negative 1/3, right? So where is that? What's the position? Well, that could be happening in quadrant 3, or it could be happening in quadrant 4. And if we're going to try to use this information to like find other trig values, or to try to draw a picture and draw a triangle that goes with it, we need to know which of those two quadrants we're in, 3 or 4. We can't really move forward unless we can figure it out. So given a trig value and a sine for another, so let's say the sine of theta is -1/3 and cosine of theta is positive. So those two things together, now this is really something, right? So sine of theta is -1/3. In particular, right, this means it's negative. So the same thing we were just doing. So that's quadrant 3 or quadrant 4. Cosine is positive. That's quadrant 1 or quadrant 4. So with those two pieces of information together, it must be the case that I'm in quadrant 4. What we're asking for here is find all the other trig values. So we can use either, right, sine squared plus cosine squared is 1, or we can draw a picture. So we can use that Pythagorean identity based on the Pythagorean theorem, or we can draw a sketch. Just because we've been working with sketches, I think that's what I'll have us do. And then you can sort of, hopefully, see why knowing which quadrant we're in is going to be important, right? Because if we're in quadrant 4, I need to sort of make a sketch accordingly. So how am I going to sort of do this? So the idea here, right, is my sine value is -1/3. So sine is supposed to be, right, my y value divided by the radius. This has got to be a negative over positive, right? So my radius is +3. My y value is -1. We'll have to do a little bit of an eyeball here, right? So if y is -1, radius is 3. So I don't know. We're kind of ballparked. Maybe out to here or something. So the idea is, right, this is 3. This is -1. And then my missing value, right, is my x. So I can do a Pythagorean theorem. I can kind of find my x. So this should be, right, kind of -1 squared plus this, like, x squared should be 3 squared. This is going to be 1 plus x squared is 9. Quick subtraction. X squared is 8. X would be the root of 8. We can simplify that down to like 2√2. And now part of what's going on here is you're saying, okay, you know, now that we're not just talking about specifically right triangles in the first quadrant, right, we're sort of in all the different possible positions. So is the x value positive or negative? So that's where this quadrant question comes in, right? So we're in quadrant 4. So that means the x value is positive. So this has got to be positive 2√2, right? Because we're in quadrant 4. So I can sub that in to my sketch, and then I can essentially just do either, right, you know, x, y, r kind of setups to get these other functions, or I can just sort of use the triangle as a reference. I'll list everything out just to sort of get it all in order. So we know already, right, sine of theta is -1/3. That means, right, sort of by definition, cosecant, we're just going to flip it, -3/1, which would be -3. Cosine, what are we going to get? So our x divided by the radius, so positive 2√2/3, roots on top, that was good to go. Flip it, secant, 3/2√2. Do a little rationalizing, right? Try to get rid of this root on the bottom. So 3√2 over 2 times 2, so that's going to be over 4. Last but not least, tangent and cotangent. Tangent should be the y value over the x, the opposite over the adjacent. So negative 1 over 2 root 2. Rationalize again, like we just did. Root times the root. This is interesting. Or no. I mean, it's not interesting, but it's slightly less interesting than I thought it was going to be. So this would be root 2 over, right, root times root is 2, 2 times 2 is 4. And then to finish us off, cotangent theta. So let's take this earlier version in red, flip that. So we'll do 2 root 2 over negative 1. So that's just going to be negative 2 times root 2. So if I have a value here, and then I know at least positive or negative sign for one other function that's not just a reciprocal, I can still do sort of make a sketch, or do this sine squared plus cosine squared is 1 kind of thing. You're doing some sort of Pythagorean theorem or Pythagorean setup in either case. And then that helps us determine whether our missing side should be positive or negative. Once we know that position, we'll know whether we're sort of going to get a positive or negative value there. Get the numbers from our Pythagorean setups, and then we're good to go. Sub all this stuff in. Not so bad.